hello and welcome. This is going to be the help video for the Factorials Worksheet. So I'll just go through some of these problems, get you started. 0 factorial, we need to know that that is equal to 1. That's just one you got to memorize. Hopefully now, you've heard it a couple times in my other video on this one, 0 factorial is equal to 1. All right, 1 factorial, also equal to 1. 2 factorial, well, that's 1 times 2, which equals 2. And then 3 factorial, that's, I'll normally actually do it 3 times 2 times 1. I think I did it ascending order in the other video, but looking at these problems here, maybe I actually like descending order better. 3 times 2 times 1 is 6. All right, expressed in factorial form, so going backwards. 6 times 5 times 4, it's got everything, so it's just 6 factorial. But what about a problem like number 8? It starts 56, 54, 56, 55, 54, but then it stops. It doesn't keep going. So I can get the start of that sequence by saying 56 factorial, but then I have to get rid of everything after 50. So that's why I divide it by 50 factorial. Not 51 factorial, because then the 51 would cancel out. You have to go one more back, and then you can get rid of that 50 by doing a 50 factorial. And then every number past 50 is going to cancel, and I'll be left with just this sequence here. So kind of a useful trick when we have a repeating sequence like that that terminates before 1. So see if you can figure out 7 on your own. All right, simplify to a single number, show your work. So we're going to use that canceling. Here with number 9, we're going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. And everything past here is going to cancel and just have 8 times 7 times 6. And that's a little bit easier to plug into your calculator and get 336. All right, what about a problem like number 11 where we've got 21 factorial on top? So let me start writing that out. All right, but then there's a 17 factorial on the bottom that's going to cancel everything else. But then there's also a 4 factorial. So these ones won't cancel on the bottom. These ones will still be on the bottom. So this is after everything is canceled. The 17 an out has canceled, so I could just write a 17 factorial here and a 17 factorial here. And those are gone. And now I just plug this in. 21 times 20 times 19 times 18. I press enter before I do the divide by, and then I do a set of parentheses. 4 times 3 times 2 times 1 if you want. Close parentheses, hit enter. I get 5,985. All right, so hopefully we can get the rest of these using the simplifying and canceling technique. Let's look at these ones here. So the technique here is when they are in a fraction like this, you take the bigger one and you start backing it up. So here we actually saw 15 in the video, so I'll do 16. This is the bigger one. N plus 1 is bigger than n. So I start backing that one up. This is now n plus 1 times, keep that in a set of parentheses, n factorial. Because I back it up 1 to n, and the factorial moves to the end. And now I can cancel out the factorial, and this is just an n plus 1 final answer. Can't be simplified further. All right, let's look at like 17. The n plus 5 is bigger, so I'm going to back that up, make it an n plus 5 times n plus 4 times n plus 3 factorial. At this point, I can cancel. And I'm left with n plus 5 times n plus 4. You should FOIL that to get n squared plus 9n plus 20. Final answer for that one. Let's look at 19. That one looks pretty tricky. So we can back both of these up to cancel with that n minus 1. So I'm going to take the n factorial, make it n times n minus 1 factorial. I'm going to take the n plus 1, make it n plus 1 times n times n minus 1 factorial. And now I've backed both of these up to the point where I can cancel out the n minus 1 factorial on the bottom. So that cancels with that cancels with that. Now I've got n times n plus 1 times n. That's the same as n squared times n plus 1, which equals n cubed plus n squared. Final answer on 19. All right, now let's use all of that to solve one of these, and then we'll leave the other one. We'll solve 21 here. So which is bigger, n minus 15 or n minus 14? Well, n minus 14 is bigger, so I'm going to back that one up. So on the top is still the n minus 15 factorial. And on the bottom, I've got n minus 14 times n minus 15 factorial. Cancels, cancels. I have to leave something behind on top, so I leave a 1 behind on top. Now let's simplify this. I've got 1 over n minus 14 equals 1 over 12. I will raise both sides to the power of -1 so that I can just get n minus 14 equals 12. Add 14 to both sides. We get n equals 26. Double check that that doesn't lead to an undefined situation. It doesn't. So that's our final answer. All right, good luck. Finish up the rest of those. Have a good rest of your day.